cables with just its own mass. And then you've also got the little metal prongs there popping up right at the center.
And then you got the 3 masses, 3 torques.
You got the 3 strings.
Strings, right?
But we can probably some of the masses. They're tiny strings.
Alright, Mr. Pat, I got my guess locked.
Go ahead.
7.
7?
My guess. My guess.
Mr. Your face.
I'm gonna go with 5.
What
to say, because of the thing in the middle.
That's right. So Jack's right on. He says, "Look, man." Now, I'm gonna do what Ryan suggests. Says, like, look, we're gonna pretend the strings aren't there because it's fine.
Oh,
Okay.
right.
Well, then you were wrong because there'll be, it's still only 5 because the strings. Right?
But I counted.
So even if you count the strings or whatever, we're gonna skip to the chase.
That would be 8 then.
We have M1G. I got M2G. I got M3G. Right? But if you look at those are all in the down direction. But my meter stick isn't accelerating downward.
So does that mean FM has to make up for all of that?
So the force by the fulcrum right here okay? Now, I don't know if that's exactly a normal type force.
Perpendicular, isn't it?
I mean, normal is like kind of a flat surface pushing perpendicular, but I'll buy it for now. That's fine.
Probably $20.
All right, are we missing anything?
The actual weight of the ruler.
Good. Here's my problem with this. The ruler is a rigid object, a uniform rigid object. How do I draw a weight vector?
From the center.
What, are you paying attention?
No.
That's wonderful. Did you guys hear what he said?
He said no. Yeah.
He said, just draw it from the center of mass. That seems like a great thing to do. All right, you ready? I would like to know which of these, if any, supply a torque, and how do you know? Check your neighbor, meow. Which of these, if any, supply a torque? How do you know?
I think everything but, well, I think 3 and the forces of the mass string in this case.
I mean, you could say that the force normal and the weight supply just 0 torque.
Well, yeah.
That's the same thing.
Well, they,
Yeah.
they don't because
I agree
they're
with you. It's
0
just those
degree
3.
angle.
Man, I really didn't.
Assad, what do you think?
Is no
Or what?
I don't think Sad's paying attention.
No, I'm paying attention. I just.
Assad, no one doubts that you're paying attention, man.
I do.
Which of these, if any, do you think supply a torque?
Everyone except the one in the fulcrum. All the forces except the force on the fulcrum itself.
So how many? 4 or 3?
3.
Because if you just pull it straight down.
Because it's a 0 degree angle, which would make 0 torque.
Oh gosh, we don't know. So according to this, if this is your pivot point, right, because that's where the fulcrum is, right? Is this a force at some radius?
Yeah.
This is a hall suite for students coming back from lunch. Teachers, please close your doors. Once you take an attendance and mark tardies, and let students in once they're there. Thank you.
Wait, guys, be alert.
If I
After our lunch.
if I heard that walking into the school, I'd go back to my car.
We just got a heads up that our lunch might.
Anyway,
Tension in a hall suite too, not just party.
does
Yeah, I
this
think it's like if-
force over here, is it at some distance from the pivot point?
Yes.
Yes.
Therefore, it can supply a torque.
Yeah.
What about this M2G?
Yeah.
What about M3G?
Yep.
But look at these two bad boys right here. There's 2 things here, right? The one that's important is, are they at the pivot point?
Yeah.
So what is the radius value for those 2?
0.
0. So can they supply a torque? No.
No.
You cannot open a door by pushing on the hinge. Right?
Depends on how strong.
I can't get this thing to rotate by pushing here.
Let me try.
Does that make sense?
I think Brian can do it.
I know it will.
Sorry about the next interruption, so just make sure, please, that all students that are coming in late get marked tardy in attendance. Thank you.
No, man.
Yeah,
Some
one of
teachers are
those.
standing up.
I didn't know. that.
Some teachers are revolting.
Just call them like, nah.
Yeah, exactly.
From lunch, I'd rather just take the
People
action.
walk all over.
Dude, I would take it too.
Okay.
I just go.
And again,
Like I have a meeting.
This one's gonna be nice because if you look at any of the R vectors here, if you look at any of the R vectors, they're drawn from the pivot point to the placement of the force. And what do you notice about those, the angle between the force vector and the radius vector?
90.
It's 90 again. Okay? And so we can see that if this is D1 here,
That'd be positive.
okay, and this is D2, and this one is D3. Okay?
So, in
Yeah.
this case, would D1 be positive in the
Well, we're gonna have to apply if it was the only one, which way would it make it go?
left?
Okay? So if this torque here, D1M1G, if it was the only one, it would get it to go,
Coming.
Anti-clockwise.
so that's positive.
And then the other two are gonna be negative.
Yeah.
I love anti-clockwise.
I know, it's
Yeah.
anti-clockwise. I'm gonna start saying that just to annoy people.
Anti-clockwise lives up in Sheboygan with Uncle Clockwise.
And Bob, your uncle?
So this makes sense to you conceptually though, because when you look at this, the torques on this side should balance out the torque on this side. The problem is, I have 300 grams on this side, but I only have 100 grams on this side. How's that possible?
So the radius of M3G is halfway between the pivot point. It's half of the radius of M1G and then M.
Oh, it might be. I don't know. I didn't do the math on this, but because this one's so much farther out,
Oh, it's gonna be.
even though the mass is smaller, it can still supply the same torque as these other two.
Okay.
What it's supplying that's different is like, it's like a, how would this relate to like the, oh, never mind, I get it.
Saad, do you get it?
Sounds like don't bother me.
He's like, man, I got something on my mind, please.
Oh, hold on.
No,
No.
it can't be done.
Wait.
No.
Is that way long?
No,
Don't do it to us.
Don't think it's that one.
Yeah.
no, no. No,
Oh, I know
no,
exactly
What's
what
the
you're
most
gonna do.
disturbing thing?
This was not kind of fun.
Might be the best part of the whole thing.
Oh,
That is just some wizardry, Mr.
Wait, what happened?
Oh, I thought it was a mistake.
The center of mass of the ruler isn't at the pivot point anymore.
yeah.
So that means the ruler is itself
I thought
applying
it was
its
just
work.
a balance.
Yeah, so did I.
Oh,
Oh,
Oh, no.
Oh.
That's not gonna work.
okay.
nice.
So what do you notice about this one?
The fulcrum is at like 70, if I had to guess.
Wait.
It's actually at 74.5.
So,
So-
with the,
So, is this accelerating linearly at all?
no.
No, not the meter stick, not any other objects, right? So the linear force is balanced. Is it accelerating angularly?
No.
So what's that tell you about the torques?
They're balanced.
So you're gonna have a torque to the right of the pivot point,
You have one to the left.
but
There's no mass.
doesn't mean you need a,
Oh,
No.
No,
A
'cause
torque
there
to the
isn't.
left of
ruler
the-
is the mass, because it's not a center, it's not
Isn't it
balanced.
the MG from the center of the ruler? Or-
so I actually like this as a framework. Let's see if that makes sense to us. Let's see if that works out.
I
Okay.
do too.
gonna have to draw it, hold on.
Make sure to comment your guys' thoughts down below.
Reply in the comments. So
Let's
put
take
your-
a break and remind
Put your prediction in the comments.
We're doing a giveaway.
Give it a reply. If you think it's in the center, give it a comment.
Yeah.
No, it just.
Merch link in bio.
Be sure to join my YouTube group and pay $100.
Wait, can you join my Patreon? How's that sound?
Hey, hey.
Get into
you gotta
the
get the
important
merch,
stuff.
get the merch out.
Just $200 a week, and I give you one.
Wait, weren't they gonna make physics shirts at one point?
Oh, someone suggested, but I was like, I can't. Okay, so,
What would they say? What would it-
It said padded on.
just say, listen, man.
They would have to say
They
it
would have to say.
All right.
Oh, I would actually buy that. That'd be
I would actually too, I'd wear it all the time.
Now, obviously, this is not to draw to scale, but this is what it looks like, true?
True.
So, how are we going to express, right? We have to draw the forces, and then we know the torques have to balance. Is that cool? So, I'll draw the meter stick again.
Oh.
What the heck was that? All right, so what do we got here? So we got one over here. Okay, we'll call this M1. So I got a little M1G, but that's all I see. Are there more forces somewhere?
Yeah, man. Get the-
Yeah.
You got them.
So there's gonna be a normal quote unquote force up from our pivot point, but then there's also gonna be the force mg doesn't come from the pivot point, it comes from the center of the mass down.
That's beautiful.
So it's MG for the meter stick, yeah?
Yeah.
And what I like about this is, given this, okay? That's exactly how to do this. Okay? That's exactly how to do this, where we're going to use the center of mass of the meter stick. We know that the normal force has to balance out these two, and the torque supplied by the center of mass of the meter stick must balance out the torque supplied by the hanging object.
I was thinking my friend, but then they do early lunch.
Oh.
I think they tutor Thursdays.
Yeah. So are you like the only tutor in the
Wednesdays is just, sometimes two other people, sometimes they don't come.
Yeah.
I don't think they're there for tutoring.
Oh, really?
Do they have you tutor AP Lang?
Who? Me? No. I mean, like, yes, commas come after periods.
Wait, what?
You want them
Use semicolons to end sentences.
here? Yes. I felt so bad.
I've been doing
This-
that wrong.
Uh-oh.
This year, I.
Jack's gone on Mr. Capacitor one too many times.
Oh, I'll beat somebody with a broom.
I will demonstrate.
So I have my broom.
And I didn't know.
Okay.
It looked like 8.
That broom thing is broken.
Okay.
Is it a working broom?
It's a magic broom.
I knew it.
All
I
right,
knew science was a lie.
pay close attention, because you're gonna.
I don't know.
This is a hard question.
Yeah.
Okay, this is a hard question, so pay close attention. Okay, so I have my broom, and what I'm going to do is I'm going to snap my fingers.
He's gonna God.
Okay,
No
What's
way.
No.
I got it.
What'd you say?
I know he's.
You're gonna fly on the broom.
no, I'm going to separate the broom into two pieces.
Oh, fuck.
It's a broken.
Man, you need to eat
Okay.
more wheat.
Oh, wait.
I need to eat
Wait,
my
wait.
Wheaties, I
With
need
that
to-
red pole, can you test the other red pole and see which one is that?
So here's the deal.
See the car.
No.
What do you notice about this right here? Where am I holding the broom?
Center of mass.
At the center of mass.
Yeah.
Does that make sense?
Makes sense.
You guys with me on that?
I am very.
So when I then break the broom into two pieces,
Sorry, man.
eat my Wheaties, drinking my milk, I want to know which weighs more.
They're the same. You were holding it right now.
I was. Check with your neighbor now which weighs more. Okay? Check your neighbor, see what your neighbor thinks. Okay?
So,
Oh, it's the broom.
I'm gonna get a max on this.
I'm gonna.
I'm gonna get a max on. I held it at the center
and
max.
the broom.
Right,
Let's say the center mass of the broom is
Oh.
like right here, and the center mass of the stick is right here. He was
No,
holding
no,
it
yeah,
like right there.
No,
Yeah, because the radius of the broom itself.
Listen, man, there's obviously a propulsion system in
And so it really
it.
depends on the
So,
distance,
with
which
that
one of
knowledge.
these two distances.
The broom weighs, the broom head weighs.
I would assume that this distance,
It's all.
It's like Harry Potter.
We're going broom.
I'm so serious.
Broom head.
Wait, Harry Potter.
Which one weighs more?
Carry that.
Which one weighs more?
They're equal.
Broom head.
Oh.
How do you?
Radius.
I thought original
Oh,
broom
okay.
head, but
Sure.
Brian is like.
Well, let's
It
put
might
this
be
on.
broom.
No, do you know who is funny? Harry Potter.
Don't make it weird, man.
Did you go to Hogwarts?
Did you go Ron?
Right.